Alright, this video we're going to move on to the third type of problems that we'll see. It's going to be a little bit more difficult. You can see we're going to use Pythagorean identities. We're going to go back to that, just like we did in 5.1 and 5.2. If we look at the first one, the 2 sine squared of x plus 3 cosine of x minus 3 equals 0, we have two different trig functions. Now it looks like a quadratic trinomial, but they're two different trig functions. If I can get them to be one trig function, then I can factor it into two binomials. And what we're going to kind of focus in on here is this sine squared of x. Now the sines and cosines are matched up. I know the first Pythagorean identity is this sine squared plus cosine squared equals 1. And when we looked at the alternate forms, like this sine squared, if I get that by itself, sine squared, it's like saying that equals 1 minus cosine squared. So this 1 minus cosine squared is the same as sine squared. I'm going to take that and substitute it in there for that sine squared of x. So when I do that, I'm going to have everything in terms of cosine. So I'm going to have 2 times, I replace the sine squared with this 1 minus cosine squared of x. Then I bring everything else down. Plus 3 cosine of x minus 3 equals 0. Okay, I want to distribute this 2 to the 1 minus cosine squared of x. So that's going to give me 2 minus 2 cosine squared of x. Okay, bring everything else down. Plus 3 cosine of x minus 3 equals 0. Now, starting to look like a quadratic trinomial. The constants 2 and minus 3, if I combine that, it gives me negative 1. So I'm going to have negative 2 cosine squared of x plus 3 cosine of x, and then this 2 minus this 3 gives me negative 1. And now you have it. You have your quadratic trinomial. So we're going to factor this into two binomials, but before we do that, we always want this leading coefficient to be positive and it's negative. So what we really could do is we could pull a negative out. So we could change the sign of all three terms, and then that negative 2 cosine squared of x will change to a positive 2 cosine squared of x. Positive 3 cosine of x changes to negative 3 cosine of x, and that negative 1 changes to plus 1. Now it looks like the quadratic trinomial where the leading coefficient is 1. So I'm going to factor this into two binomials. Since it's 2 cosine squared of x, well then one of them has to be 2 cosine of x, and the first term for the other one has to be cosine of x. And then you really don't have any options. This last term's 1, and you're going to have both minuses in here, so the only factors of 1 we have is 1 and 1. And if you FOIL that out, the 2 cosine x minus 1 times cosine of x minus 1, it gives you this back, this quadratic trinomial. So then the whole hard work is really done. Then we just take each factor and set it equal to 0. So for this, if the 2 cosine of x minus 1 equals 0, then when you isolate that cosine of x, it equals 1/2. This one right here, if cosine of x minus 1 equals 0, well then cosine of x equals 1. Now we just go back to the unit circle and we get our angles. Now cosine, this is positive in the first and third quadrant. Or not third quadrant, first and fourth, and it's the x value in the unit circle is 1/2 at pi over 3, so it's pi over 3, and it is 5 pi over 3. And let's go back up. Let's look at the directions. Okay, the directions, you can see it says 0 to 2 pi, so I don't have to add in that 2 pi k, so I just leave it as pi over 3 and 5 pi over 3. And then here I only get one angle. The x value in the unit circle is 1 only at 0, where you could say 2 pi. So those are your three answers: pi over 3, 5 pi over 3, and 0. So, you know, these ones right here, you're going to have two trig functions, and you can use one of the Pythagorean identities to substitute in another trig function so you all have the same trig function.